Why does a species born on a tiny blue dot think it can conquer the stars? What if the survival of humanity depends not on the technology we have today, but on decisions made a century in advance? And most importantly, what if the next great leap isn't for the sake of exploration, but because we have no other choice? In the next 100 years, the way we think about space will transform not just our future, but our very identity. As we look ahead to the next century of space exploration, we first need to examine where we are today and where we're headed in the next decade. Right now, space agencies like NASA and ESA, along with private companies like SpaceX, are laying the groundwork for the future of interplanetary travel. We've got ambitious missions in the pipeline. NASA's Artemis program aims to return humans to the moon, not just for a quick visit, but to establish a sustainable presence. The moon could serve as a stepping stone for deeper space exploration, providing us with a testbed for long-duration missions, resource utilization, and even habitats. Meanwhile, SpaceX is pushing the boundaries with its Starship, designed to be a fully reusable spacecraft capable of taking humans to Mars. This is where the next big leap begins, moving from robotic explorers like the Mars rovers to human boots on the Red Planet. It's not just about reaching Mars, it's about surviving and thriving there. Colonizing Mars, or even the moon, will require breakthroughs in propulsion technologies, such as ion thrusters, or even nuclear-powered rockets. These are critical for making space travel faster, safer, and more efficient. But it's not just government agencies aiming for the stars. The rise of private space ventures is driving the commercialization of space like never before. Space tourism is quickly becoming a reality, with companies like Blue Origin and Virgin Galactic offering suborbital flights. And it doesn't stop there. Space mining and manufacturing in orbit could revolutionize industries here on Earth. The early 21st century is laying the foundation for a future where space isn't just a frontier for exploration, but a place where people live, work, and build new societies. This decade, from now to 2030, is crucial for setting the stage. It's a time of unprecedented cooperation, with countries and private companies joining forces to take these early steps beyond Earth. What we achieve in the next few years will define our path forward for the next century of space travel. As we move into the 2030s and 40s, the vision of permanent colonies on the Moon and Mars starts to become a reality. This is where things get truly groundbreaking. We're not just talking about landing astronauts for brief stays anymore, we're building actual communities that can sustain human life long term. The Moon, with its proximity to Earth, is likely where we'll see the first permanent outposts. These bases will serve as critical hubs for scientific research, resource extraction, and even as a launch pad for missions to Mars and beyond. But setting up shop on the Moon or Mars is no small feat. One of the biggest hurdles is radiation protection. Unlike Earth, these celestial bodies don't have a strong magnetic field to shield us from cosmic rays and solar radiation. We'll need to develop advanced habitats, whether that means building underground or using regolith, the surface material of the Moon and Mars, to create thick protective barriers. Life support is another challenge. These colonies will rely on closed-loop systems that recycle air, water, and other essentials, but the question is, how efficient can we make them? Then there's the issue of resources. Establishing a colony in space is one thing, but sustaining it is a whole other challenge. That's where mining comes in. Extracting resources like water from lunar ice or utilizing Martian soil to create building materials could reduce our dependency on Earth for supplies. Water can be split into oxygen for breathing and hydrogen for fuel, making it a vital resource. The more we can rely on local materials, the more sustainable and scalable these colonies become. AI and robotics will play a huge role in all of this. We'll need autonomous robots to handle tasks humans can't, whether it's building infrastructure before astronauts arrive or maintaining equipment in harsh conditions. These technologies are going to be the backbone of off-world construction and day-to-day operations, allowing us to build and maintain colonies in environments that are far too extreme for us to handle directly. In the 2030s and 2040s, we'll see the dawn of space settlements where humans start to call these distant worlds home. As we progress into the mid-21st century, One of the most exciting developments will be the rise of the space economy. We're talking about industries that are entirely off-world. Things like space mining, energy generation, and manufacturing that could redefine how we live, work, and build on Earth and beyond. Let's start with space mining. Asteroids are essentially giant treasure troves floating through space, packed with valuable resources like metals, water, and even rare minerals. Mining these celestial bodies could provide the raw materials needed to support colonies on the Moon and Mars, and potentially fuel technological advancements on Earth. One of the game changers will be the ability to extract and use resources directly from space. Imagine harvesting water from asteroids to create fuel or mining metals that are rare on Earth but abundant in space. This could make space exploration more self-sufficient, reducing the need to send heavy and expensive materials from Earth. It's a bold vision, but companies are already making strides in this direction, with plans to capture and mine asteroids within the coming decades. Energy will also be a critical piece of the puzzle, not just for space colonies but for Earth as well. Solar power satellites, massive arrays of solar panels in orbit, could collect energy from the sun 24/7 and beam it back to Earth. These satellites could supply clean, unlimited power to our planet, solving some of our biggest energy challenges. Imagine a future where the energy we use on Earth is harvested from space, an energy revolution that transcends borders and eliminates reliance on fossil fuels. Plus, the same technology could power our off-world colonies, providing a sustainable energy source in space. Then there's space manufacturing. The microgravity environment of space offers unique opportunities for building things that simply aren't possible on Earth. Whether it's new materials, pharmaceuticals, or even three-dimensional printing large structures, space manufacturing could transform industries. Imagine building massive solar power stations or space habitats entirely in orbit, without the constraints of Earth's gravity. This would not only drive innovation, but could also lower the cost of space missions and make space expansion more feasible. Ultimately, the space economy will be integral to humanity's future in space. It won't just be about exploration, it'll be about creating new industries, new jobs, and new ways of living. This economic expansion will fuel the technological advancements and infrastructure needed to support life beyond Earth. Space won't just be a destination for scientists and astronauts, it will be a thriving frontier for industry, commerce, and human civilization. As we push into the 2040s and 2050s, humanity's ambitions will stretch beyond Mars, reaching out into the farthest corners of our solar system. The next great frontier will be the moons of Jupiter and Saturn, places like Europa, Titan, and Enceladus. These icy moons hold incredible potential. Europa, for example, is thought to have a massive ocean beneath its frozen surface, making it one of the most promising locations to search for life beyond Earth. Imagine the scientific breakthroughs that could come from sending human explorers or advanced robotic missions to drill through Europa's ice and explore its subsurface oceans. Titan, with its thick atmosphere and lakes of liquid methane, offers an entirely different set of challenges and opportunities for exploration. Establishing human outposts in these distant regions is no longer pure science fiction. We're looking at the possibility of setting up research stations on these moons, much like we have done in Antarctica. But getting there, and staying there, will be a monumental challenge. Travel times to the outer solar system are far longer than journeys to the Moon or Mars. A mission to Europa or Titan could take years, requiring spacecraft that can sustain life over vast distances and durations. The challenges aren't just in the travel time, but also in the harsh environments. Extreme cold, high radiation levels, and the need for advanced life support systems that can operate far from Earth's support. The asteroid belt also offers a wealth of possibilities. Human outposts there could serve as mining hubs, tapping into the vast resources of these ancient rocks. As technology advances, we might see small colonies or research bases on these asteroids, potentially acting as refueling stations for missions venturing even deeper into space. The asteroid belt could be a key stepping stone for future missions, providing both resources and strategic locations for future space infrastructure. But to truly explore the outer solar system, we'll need breakthroughs in propulsion technology. Traditional rocket systems, which rely on chemical fuels, simply won't cut it for these long-distance missions. That's where next-gen propulsion systems come into play. Ion thrusters, nuclear propulsion, and eventually nuclear fusion could drastically cut down travel times, making these distant worlds more accessible. Fusion propulsion in particular holds incredible promise. It could provide nearly limitless energy, allowing spacecraft to travel farther and faster than ever before. The journey to the outer solar system is a new frontier of its own, filled with challenges, yes, but also endless possibilities. It's a realm where science, engineering, and human ingenuity will be pushed to their limits as we expand our presence beyond the inner solar system, stepping into the unknown on a quest for discovery and survival. One of the more immediate advances we're likely to see is nuclear thermal propulsion. Instead of burning chemical fuel, nuclear thermal engines use heat from a nuclear reactor to superheat a propellant like hydrogen. This method could provide much higher efficiency than chemical rockets, cutting travel time to Mars, for example, from 6 months to just a few weeks. Faster travel times mean less exposure to harmful space radiation and more flexibility for human missions. While nuclear propulsion isn't without its challenges, mainly around safety and politics, it's one of the most promising next steps for near-future missions. But the real game-changer will come with fusion propulsion. Fusion-based drives, which mimic the process that powers our sun, could provide nearly limitless energy. Imagine spacecraft powered by small fusion reactors, capable of accelerating continuously and achieving speeds that chemical rockets can only dream of. This technology would open up the solar system, making trips to the outer planets like Jupiter and Saturn much more feasible. Fusion propulsion could bring the travel times down from years to months or even weeks, turning what used to be unimaginable distances into achievable goals. Then there are the more theoretical concepts, things like antimatter propulsion and even warp drives. Antimatter drives would use the energy released when matter and antimatter annihilate each other, producing an incredible amount of thrust from a tiny amount of fuel. Theoretically, this could allow spacecraft to reach a significant percentage of the speed of light, making interstellar travel a real possibility. However, the technology to create and store antimatter at the necessary scale is still far from reality. And what about warp drives? It's a concept straight out of science fiction, but physicists have begun exploring the theoretical framework for bending space-time itself. A warp drive wouldn't move a ship through space in the traditional sense. Instead, it would compress space in front of the ship and expand it behind, essentially warping the space around the vessel to achieve faster-than-light travel. While we're still in the realm of theory here, it represents the ultimate propulsion breakthrough, one that could one day allow us to explore not just our solar system, but distant stars and galaxies. Each propulsion breakthrough brings us closer to exploring the deeper reaches of space. Faster travel means we can send humans further than ever before, beyond Mars, to the moons of Jupiter and Saturn, the asteroid belt, and eventually even to neighboring star systems. What might seem like science fiction today could very well be the technology that defines the next century of space exploration, pushing humanity ever closer to becoming a multi-planetary species. As we venture deeper into the solar system, the question of where and how we'll live becomes a central challenge. One of the most ambitious ideas for solving this problem is terraforming, essentially transforming a hostile planet like Mars into an Earth-like environment where humans can live without the need for spacesuits or enclosed habitats. The concept sounds like something out of science fiction, but scientists are already exploring the possibility. Terraforming Mars could involve releasing greenhouse gases into the atmosphere to warm the planet, melting the polar ice caps to create oceans, and even creating a magnetic field to protect against solar radiation. But the science of terraforming is still in its infancy, and the ethical questions are huge. Should we reshape an entire planet for our benefit, potentially disrupting any existing ecosystems, no matter how primitive? What if there's microbial life on Mars? Do we have the right to transform its environment? These are questions that humanity will have to grapple with as we look toward making other planets habitable. While terraforming offers a long-term vision of planetary colonization, it's a project that could take centuries, if not millennia, to fully realize. In the meantime, we'll likely rely on large-scale space habitats, artificial environments that can support human life. Concepts like O'Neill cylinders and the Stanford torus have been around for decades, offering potential solutions for living in space without the need to terraform entire planets. These massive structures would rotate to create artificial gravity, with ecosystems designed to mimic Earth's atmosphere, weather, and even landscapes. Imagine living in a floating city with lush greenery, rivers, and farmlands, entirely self-contained and floating in the void of space. These habitats could house millions of people, providing a solution for population expansion beyond Earth, while protecting us from the challenges of distant planetary environments. The creation of self-sustaining ecosystems is key to making these habitats work. We'd need closed-loop systems that can recycle air, water, and waste, much like Earth's natural systems. Advances in biotechnology could allow us to design crops and organisms specifically tailored for life in space, creating ecosystems that thrive in microgravity or even the harsh conditions of deep space. These habitats wouldn't just be survival shelters. They could become vibrant, thriving communities that expand humanity's presence across the solar system. And then there's the possibility of not just modifying planets, but modifying ourselves. As we look to colonize the harsh environments of space, we may also need to rethink human biology. Genetic engineering or cybernetic enhancements could help humans adapt to lower gravity, higher radiation, or extreme temperatures. While it sounds like science fiction, there's already research being done into how we could modify human genes to resist radiation or improve bone density in low-gravity environments. These advancements could make it possible for future generations to live and thrive in space, not as fragile Earthbound beings, but as a species fully adapted to the cosmos. Terraforming planets, building space habitats, and even altering human biology represent the next giant leap for humankind. Together, these advancements could reshape our future, allowing us to thrive in environments once considered impossible, and ultimately making space not just a place we explore, but a place we call home. As we move into the second half of the 21st century, the dream of sending probes beyond our solar system starts to come into focus. One of the most exciting projects in this area is an initiative that aims to send tiny light-powered probes to Alpha Centauri, the closest star system to Earth. Using powerful lasers based on Earth, these probes would be accelerated to a significant fraction of the speed of light, allowing them to reach Alpha Centauri in just over 20 years, a mind-boggling achievement considering how far that is. This would be our first step into truly interstellar exploration, giving us a glimpse of what lies beyond our solar neighborhood. But interstellar travel comes with its own set of challenges, especially when it comes to communication. Once these probes are sent out, it will take years for their signals to reach us due to the vast distances involved. For example, even at the speed of light, a signal from Alpha Centauri would take over 4 years to get back to Earth. This creates huge challenges for mission control, as real-time communication simply isn't possible. Instead, these probes will need to operate autonomously, making decisions on their own as they travel through the void. Why Alpha Centauri? This star system holds immense significance. Not only is it the closest, but its smaller red dwarf star, Proxima Centauri, has a planet in the habitable zone, Proxima Centauri b. This planet could potentially have conditions suitable for life, making it one of the most intriguing targets in our search for extraterrestrial life. Even though the chances of life are still unknown, sending probes to these nearby star systems will help answer some of humanity's biggest questions. Are we alone, and what are other star systems really like up close? Beyond robotic probes, the possibility of sending humans on interstellar missions is still further off, but the groundwork is being laid now. For long-term missions that could take decades or even centuries, we'll need significant advancements in spacecraft propulsion and life support. Technologies like nuclear fusion propulsion could make human interstellar travel possible by dramatically reducing travel times, but we'll also need breakthroughs in artificial intelligence, cryonics, or even generational ships, where multiple generations of humans would live and die aboard the spacecraft, as it makes its journey across the stars. These missions represent the ultimate challenge in space exploration, pushing the boundaries of our technology and imagination. If we succeed, it would mark a profound moment in human history. The moment we become an interstellar species, reaching beyond our home system and beginning to explore the galaxy itself. The 2050s to 2080s will be an era where humanity steps into the unknown, driven by curiosity, technology, and the desire to understand our place in the universe. As we delve deeper into the age of space exploration, the role of artificial intelligence and automation becomes more critical than ever. AI will be the backbone of managing complex space operations and habitats. Imagine a future where autonomous systems oversee everything from monitoring the health of a space station to optimizing resource allocation in off-world colonies. These AI-driven systems will take on the heavy lifting, allowing humans to focus on research, exploration, and problem-solving, essentially making our lives in space much safer and more efficient. Robotic mining and construction are set to revolutionize how we extract resources and build infrastructure in space. Picture autonomous ships mining asteroids for precious materials, or drones constructing habitats on Mars while humans provide oversight from afar. AI can manage these processes with precision, ensuring that everything runs smoothly, from logistics to environmental control. With the ability to analyze vast amounts of data in real time, AI can help us make informed decisions, predict potential issues, and adapt to the unpredictable nature of space. As we venture into long-duration space travel, human enhancement technologies will play a pivotal role in our survival. Advances in biotechnology, genetic engineering, and even neurotechnology could enable us to adapt to the unique challenges of life in space. For example, we might develop enhancements that improve our resistance to radiation, or alter our biology to cope better with low-gravity environments. Imagine a future where humans can thrive in the harsh conditions of space, equipped with technologies that allow us to not only survive, but also flourish. However, this merging of human biology with advanced technology raises important ethical questions. As we enhance ourselves for life beyond Earth, we must consider the implications of such changes. What does it mean to be human if we start altering our biology to such a degree? Will we create a divide between those who have access to these enhancements and those who do not? The prospect of human enhancement in space presents a complex moral landscape that we must navigate carefully. As we push the boundaries of exploration, we also need to ensure that our humanity remains at the forefront of our advancements. In this brave new world of space exploration, AI, automation, and human enhancement will redefine not just how we live and work among the stars, but also who we are as a species. As we look ahead to the final decades of the 21st century, humanity stands on the brink of becoming a multi-star system species. The vision of sending human missions beyond our solar system shifts from the realm of science fiction to an impending reality. Picture it, astronauts embarking on journeys to distant stars, fueled by the technologies and innovations we've spent decades developing. This is not just a leap in distance, it's a leap in human experience and understanding as we venture into the cosmos in ways our ancestors could only dream of. However, traveling to another star system comes with a unique set of psychological, social, and technological challenges. Life in interstellar space will be drastically different from what we know. The isolation and confinement of a spaceship traveling for years, possibly even decades, will test the limits of human resilience. Crews will need to maintain their mental health and social cohesion during these long journeys, leading to new approaches in group dynamics, conflict resolution, and community building. How do we foster relationships and a sense of normalcy in an environment where Earth is just a distant memory? These are questions that will require thoughtful answers as we prepare for life among the stars. To address the vast distances involved, we may rely on concepts like sleeper ships, generation ships, or cryogenic travel. Sleeper ships would allow crew members to enter a state of hibernation, waking only when nearing their destination, significantly reducing the psychological toll of long voyages. Generation ships, on the other hand, would host multiple generations of people, with descendants continuing the mission long after their ancestors have passed away. This idea shifts the focus from individual missions to a collective journey, where a community grows and adapts over time as they travel toward new worlds. And what awaits us in these distant star systems? The exploration of exoplanets, those intriguing worlds orbiting other stars, will be a major focus. With advances in telescope technology and detection methods, we'll be able to identify potentially habitable planets, looking for conditions that could support life. Imagine landing on a distant exoplanet, stepping onto a new world, and discovering an environment that may or may not resemble Earth, with its own unique ecosystems and possibly even life forms. The thrill of such discoveries could redefine our understanding of life and our place in the universe. As we look forward to what life might be like in 100 years, we can envision a future where space colonies evolve into independent societies, each developing their own identities and ways of life. These colonies, whether on Mars, the Moon, or even in the asteroid belt, may start as outposts of Earth, but over time they'll grow into vibrant communities with unique cultures, traditions, and social structures. Imagine living in a society that has adapted to the low gravity of Mars or the harsh environments of asteroids, where daily life is shaped by the challenges and opportunities of space. With this evolution, we might see entirely new forms of governance emerge. As these societies become more autonomous, the need for Earth-centric governance will lessen. What could governance look like in space? We could witness the rise of democratic models that are more direct and participatory, perhaps leveraging technology to facilitate decision-making across vast distances. On the other hand, we might encounter novel systems of governance inspired by the unique challenges of living in space, where cooperation and resource sharing take precedence. The social dynamics of space communities will differ from those on Earth, potentially leading to innovative ways of organizing society and addressing conflict. Then there's the intriguing concept of post-humanity. As we modify ourselves through technology and adapt to life in multiple star systems, what does it truly mean to be human? In this future, the lines between human, machine, and something entirely new could blur, creating beings that are capable of thriving in environments we can't even imagine today. This evolution may challenge our understanding of identity, relationships, and community, prompting profound philosophical questions about our essence as humans. Furthermore, the development of new economies, art, and science in space will shape these future societies. Imagine economies that operate beyond the traditional models of supply and demand, focusing instead on sustainable resource management and collaboration among colonies. Trade could extend beyond just goods to include ideas, culture, and innovation. As for art and culture, they will flourish in ways we can't fully predict, perhaps inspired by the beauty of distant stars, the harshness of alien landscapes, or the shared experiences of humanity's journey among the stars. Science, too, will evolve, driven by the unique challenges of living in space, from advances in life support systems to breakthroughs in terraforming and beyond. In this future, life will be rich and complex, shaped by our experiences and adaptations to new worlds. Humanity will not just survive, but thrive in ways we can hardly imagine today, drawing on our creativity, resilience, and curiosity to explore the vast tapestry of existence among the stars. The next century promises to be a time of incredible transformation, as we redefine what it means to be human and what it means to live in a universe filled with possibilities.